the dance of creation and destruction. Imagine that right now, in some distant corner of the universe, a grand cosmic tragedy is playing out. A huge star that has been holding back the onslaught of its own gravity for millions of years suddenly explodes into a brilliant flash of light that outshines entire galaxies. This explosion is a supernova. It marks the death of a star, but it actually gives birth to life. This fiery inferno gives birth to the chemical elements that make up planets, oceans, air, our bodies, and everything we know. But what exactly happens inside a supernova? How does this destructive force create matter? And could such explosions be the cause of life in the universe? Let's look inside this cosmic cataclysm and find out how supernovae shape the elements and change the fate of the universe. What is a supernova? Supernova are some of the most powerful events in the universe. They happen when the mass of a star becomes too great to keep itself from collapsing. There are two main types of supernova. Type 1 supernova. These are explosions caused by white dwarf small but extremely dense stars. They steal matter from a neighboring star until they exceed the Chandrasekhar limit, 1.4 solar masses. At that point, the dwarf fails and instantly tears itself apart, creating a colossal release of energy. Type 2 supernova. These occur with massive stars more than 8 solar masses that survive to the end of their life cycle. Complex nuclear reactions take place in their core, forming ever heavier elements. But when the core becomes iron, it stops releasing energy, and the star collapses under its own gravity. The pressure inside becomes so enormous that an explosion occurs, scattering stellar matter in all directions. But what happens inside the supernova at this moment? How does a supernova create chemical elements? Before the explosion, nucleosynthesis, the process of creating atoms, is already underway inside the massive star. It's like a layer cake. The outer layers contain hydrogen H and helium He, carbon C, oxygen O, and neon Ne. Go deeper. At the very center is iron Fe. But it is the supernova explosion that produces elements heavier than iron. Cobalt Co, nickel Ni, copper Cu, silver Ag, and other metals are formed under tremendous pressure and temperature. Gold O, platinum Pd, and uranium U are formed by the R process, where neutrons are captured by the nuclei of atoms at insane speeds. This process happens in mere seconds, but its effects change the chemical composition of the entire universe. How do supernova form planets and life? Fact: every atom of oxygen we breathe in, every iron in our blood, every gold in our jewelry, all created in the interior of stars and blown apart by supernova. When a star explodes, the ejected elements mix with interstellar dust to form new clouds of gas. Over time, these clouds become planets, asteroids, and even new stars. Examples: the solar system formed from the remnants of an ancient supernova that exploded long before the sun was born. Carbon, hydrogen, nitrogen, and oxygen, which are essential for life, are the cosmic legacy of the stars. The iron in our blood is the dust of dead stars. You could say we are all children of supernova. What is left behind after a supernova? There are some amazing objects left behind after a star explodes. Neutron stars. They contain so much matter that a teaspoon of matter would weigh billions of tons. Their magnetic fields create the powerful radio signals we call pulsars. Black holes. If the mass of the core of a star after an explosion is greater than 3 solar masses, it shrinks into a point of infinite density. A black hole is born. Supernova nebulae. The ejected gas forms bright structures, such as the Crab Nebula or Cassiopeia, that remain visible for thousands of years. Could supernova threaten Earth? What if a supernova explodes near us? Although supernova explosions happen frequently, they usually occur at safe distances. However, if a supernova happens less than 50 light-years from Earth, the consequences could be catastrophic. Gamma radiation will destroy the ozone layer, exposing the surface. Too harsh radiation, the shock wave will lead to climate change. The particle flux will change the chemical composition of the atmosphere. One of the candidates for a supernova is the star Betelgeuse. It could explode at any moment, but is fortunately at a safe distance from us 6 light-years away. How do we study supernova? Today, astronomers use powerful telescopes and satellites to follow exploding stars in real time. The James Webb Telescope analyzes the chemical composition of supernova. The Vera Rubin Observatory looks for new flares in the sky. Radio telescopes are recording the remnants of explosions to study magnetic fields. In the future, we may be able to accurately predict the explosion of nearby stars and perhaps even harness the energy of supernova in space technology. Conclusion. We are stardust. Supernova are destruction leading to creation. They create everything around us. The atmosphere in which we breathe, the soil we walk on, the water we drink, even the thoughts in. Our heads are the result of processes that began in the stars. We are all descendants of ancient supernova. If you enjoyed this journey into the bowels of the universe, don't forget to like and subscribe. The cosmos is still full of mysteries, and we'll be sure to uncover them.